Morning pre-calculus class. So today I want to talk about the polar coordinate, section 8.1 from the James Stewart. Okay, so we'll look at that, the warm-up first. So it looks like this one, it's linear versus the non-linear equations. So you can say that's a combination. It's a linear and a non-linear system. So just want to sketch the graph for this so you'll find out the point where they intersect. The purpose of doing that, this one is linking to finding the point where they intersect. So it's very good for calculus, especially once you need to find out the area bounded between two curves. So you can see that from one of my videos that I put out for calculus there. So it's kind of related. Okay, so 8.1, so we'll look at this. Again, this one is coming out from James Stewart, Pre-Calc, the 5th edition. So 8.1 polar coordinates. So polar coordinates. So usually we use the Cartesian coordinates, which are direct distance from two perpendicular axes. Cartesian, that means xy coordinates. And Newton came up with more convenient and useful coordinate systems called the polar coordinate. So once we convert that to r and theta, r which is the radius, theta which means the angle, so we use that the polar system. So let's say that we do have a pole. Okay, so let's say that's from the xy coordinate, it's the origin. And we do have a polar axis. It's a horizontal, it's just the x-axis. And then we do have a point somewhere up there. So let's say that point is x comma y. And then the distance from the pole, the origin, to the point, it's called the radius. And then the angle right between the x-axis and that radius, it's always considered the direction, which is theta. Okay. So that point, instead of using x comma y, and also can be represented by r comma theta. And then we'll talk about the way to convert it from xy coordinate, the Cartesian coordinate, to the polar coordinate. So let's say that we plot the point, so 2 comma pi over 3, so for the polar coordinates, so you started with the x-axis. And then the direction, it's pi over 3, which is 60 degrees. And then we do have a point here, so in order to get that point, so you want to measure the distance from the origin to the point. So it's about 2 units away. Okay, so that one is 2 units away. So you count it, so it's 2 units. And here's another one, so negative pi over 3, so we're going by clockwise, because that's a negative radian. And then the radius is also 2. So it's 2 units from the origin, the pole, all the way to the positions. So 2 units. And here's another one, so pi over 3, so negative 2, so that means we're going to the negative direction. So that means it's reflected over the origin. Okay, because that negative, radius cannot be negative because radius is always the distance. But negative, it shows the direction, it's a reflection. So it's reflected over the origin. It's a point of reflection. And here's another one, negative pi over 3. So it's supposed to be down here in quadrant 4. But now it's negative 2. So if that's negative 2, it's reflected over the origin. It's a point of reflection. Okay, so it's going back to the top. So negative 2 units. Okay, so now let's see what else that we have, polar coordinates. So let's say we do have a right triangle here. So cosine of theta can be found by using x over r. And then sine of theta, well, let's just solve for x first. So x, that means, can be written as r cosine of theta if you try to cross multiply it. And then sine of theta, it's y over r. So therefore y equals r sine theta. And one thing that we noticed from the circle, so x squared plus y squared equals r squared, or using the Pythagorean theorem. So in other words, tangent of theta equals y over x, because that tangent with the right triangle there, we do have opposite over adjacent. So find the rectangular coordinate of each point with the given polar coordinates, rounded to the nearest 100 if necessary. So we do have a radius, and we do have theta. So that means we want to use those formula, x equals r cosine theta. So 4 cosine of 3 power 4. So cosine of 3 power 4, according to the unit circle, is negative root 2 over 2 times 4. So we got negative 2 root 2. And then y equals r sine theta. So equals 4 sine of 3 power 4. So we got 4 times root 2 over 2. So we got 2 root 2. So find the rectangular coordinate of each point with the given polar coordinate. Round to the nearest hundred if necessary. Again, using the formula, so plugging into the calculator, so we end up with 0.44 for x. And then y will end up with negative 0.90. So xy coordinate, so this one is showing that it's in quadrant 4. Because the radius is negative. So it's reflected over the x-axis. So here's the one that I can try. Find the rectangular coordinate of the given polar coordinate. Round to the nearest hundred if necessary. Okay, so similar to what we done earlier. And graphing the polar curve. So with the graphing calculator, sketch this equation. So we do have r equals 2, so it looks like that one's going to be a circle. And r equals 2 cosine of theta, we'll find out. So most likely it's going to be like a circle. So r equals cosine of 2 theta. So double angle identity of cosine of 2 theta. So r equals 1 plus sine theta. So that one is the cardioid. So we'll take a look at that. The shape. This one basically can just use that graphing calculator. Convert that to from xy coordinate. So use that the polar coordinate on the setting menu. So we'll have one other video for this type of graphing calculator problem. Okay, so you'll see like all those shapes. Okay, so thank you for watching it today. So I'll see you guys next time.